So since the morning, we've been hearing about security, about all the tools that you would use for ensuring security and all that going around. So that's one thing. However, what I wanted to talk about today is like, how can you test if those security tools are even working? How can you test if your system is foolproof when those tools are there and your system is even breakable, or what all things in your system need protection when those tools are not present there? So I'm going to be talking about how we have been doing this adversarial emulation at AccuKnox, how we use some tools, some open source tools, and our journey, like what have we been doing for this in the past and how we came to this. So a little bit about myself. I am Rudraksh. I'm a software engineer at AccuKnox, where I closely work with users and implement the things that they want on the code side. And that's what my day looks like. And I'm also a maintainer of KubeArmor. I guess you have heard about the project since a couple of times since today morning. And I'm also a regular mentor in programs like Google Summer of Code, GSOC, LFX mentorship, and so on. So going further, so adversarial emulation, let's start with what it really is. Basically, it's a threat-focused approach where you do some operations against a system to analyze how it's doing. Like, are there any security holes? And if any attacker does try to gain access, like there has been a set of techniques, tactics, procedures that have been given by frameworks like MITRE, the attack framework. And what adversarial simulation refers to is you simulate some of those scenarios and try to see if your system will withstand against those. I think you might be wondering, this sounds a little similar to penetration testing. Penetration testing is, however, like you just go about finding vulnerabilities, finding exposures, and so on. Adversarial emulation is more focused on techniques. And you would now ask, why would someone do adversarial emulation or anything like this? So we have mainly recognized 3 use cases. One of them is security assessment of your system. For like I mentioned, you are an organization, you are buying a security product, you want to assess if that security product is working, or even before you buy that product, what areas of your system would you need to cover. So basically red teaming in your system. Then the below 2 use cases are specifically to our use case, like how we have been using it, because as a security vendor, we need to engage with customers and showcase them the capabilities of our platform. So that's one thing that we use adversarial emulation for. And the third thing is platform assessment. This is again assessing if your security tools are working. And we ourselves internally use all these techniques for ensuring that what we are creating works. So how did we used to do all this earlier? It was like whenever we were presented with a problem, we were presented with a workload, or we were presented with a new vulnerability, the thing that we do is we analyze the threat model, like what is this system looking like, what all holes are present in there, and what all could be exploited, and so on. And the next step would be like to showcase. We would cause some havoc on the system, like run some commands and break some stuff. And then we would install our solution or KubeArmor or AccuKnox. And then again, we will cause the same kind of havoc and show that, okay, you have our system in place, you are protected now, and so on. So this process was becoming a little tedious and boring. We had all these scenarios, and then the need to keep maintaining these grow, because you have new vulnerabilities being discovered every day, right? And you have all different kinds of workloads as well. So we had to take care of this. And then there was also the need that we had to train people on how to showcase these things, how to test our systems, and so on. And that's where we came across this tool, Caldera. And Caldera is an open source tool by MITRE. MITRE are the same folks who created the attack framework and other frameworks for security, compliance, and so on. And basically, at a high level, what Caldera is, it is a server which has some plugins. So if you see on this page here, this is how we've been using Caldera at AccuKnox right now. We have a hosted server, and then we have these plugins or agents. These agents, they get installed on the environments where we want to actually inject some commands or do our testing. And then like we access the Caldera UI. Caldera exposes a REST API as well as a UI which you can use, and through that UI we create a set of commands, and we store them there for specific to workloads or specific to any other things. And then whenever we want to test a system, we just automatically like run those things. I'll show them again here. But yeah, keeping them there, storing them all has allowed us to create a specific knowledge base. And we've been using those knowledge base for repeated demonstrations and so on. A little bit about Caldera, I'll also go through them while the demo, but Caldera is broken down into some parts. The part that gets installed on the premises where attacks has to be done is called the agent. It would run your instructions. And then there are abilities. Abilities are the low-level commands. And adversaries are group of abilities. You can create your own adversaries. You can do as you like. And operation is an execution of adversary. It would be similar to how hacker groups run campaigns of their attacks and so on. So how we've been using Caldera for using it as a knowledge base for all the clients that we have. We deploy like the central Caldera stores all the vulnerabilities, all the abilities that we want to simulate, and then we deploy this agent across the clusters where it has to be tested. And the workloads there could be variable, but all that is stored in our knowledge base. And then we have the central control to showcase it from the environment that is hosted. So what I'm going to do next is showcase like how does Caldera look. I'll bring up the screen. Okay, you can see the screen. So this is Caldera, and the moment you open it, you will see the nice UI, and there is this thing called agent. So agents is what all things are connected to the central server. I would quickly deploy an agent on my cluster. So I have a GK cluster here, and you see it has some workloads already running, and Vault is one of them. Vault is going to be the scapegoat of my demo today. I'll be performing attacks on it. So I'm just going to deploy my agent, and the agent is simply a deployment, and it's having escalated privileges. It uses a cluster admin role so that it can do all the things that any attacker in the worst case scenario would be able to do. So the moment it is created, you would see that it starts to pop up here, and this thing which allows us to have multiple user environments is group. So Caldera comes with this ability of grouping. AccuKnox KubeCon is the group that I set for this particular agent that I just deployed. And you can set it to anything, and it would reflect here. And after that, this is the set of abilities. Now Caldera ships out of box with some of the abilities that you could use, and these are based on best practices recommended by them. You can see the TTPs associated with them present here as well, or you can go here and create an ability, and I won't fill this all, but you specify a tactic, you specify a technique ID that's specific to, again, specifics to MITRE. The another important thing here is like when we do this, we get the ability to have a portable set of instructions, because the ability can run anywhere. Like you can set here if you want to run these on Darwin, Linux, Windows, whatever operating system, then you will specify and a lot of commands. So we have created a set of abilities for Vault specifically. I'll go through some of them. For example, in Vault, you have a sensitive mount points where data is stored, like keys and all. So this basically does an LS there. So this is a simple one. Another one I could show is this one, which basically goes into the Vault pod, and it like tars, it creates a copy of the actual data and replaces it with some bad data. So all these have been created by us, and we keep doing this exercise. And then what we do is we create an adversary. Adversary is a plan of action that we will be doing. So I have Vault attack at KubeCon. This is the adversary that I'm going to do today, and this is going to run some commands. Some of them are related to, like I showed, and other is basically running a cryptominer. I'll get to what all vulnerabilities are present here and so on. So you just have to save, and then you can launch an attack campaign. And I'll select an adversary. Where is our adversary? Yeah. And I can select what groups I want to. AccuKnox contains other groups as well, so I'm going to only target the AccuKnox KubeCon. And the moment I launch it, it will start simulating all those scenarios in cluster. You can see the command, and soon enough you'll get the output as well. So meanwhile these execute, I want to throw some light on the scapegoat that we are using today itself, the Vault basically. So this is what an on-premises deployment of Vault looks like. You have within your cluster some microservices, and then there is Vault deployed. Within Vault, there are some volume mount points, and those volume mount points are being used for storing your secrets. So /vault data, /vault config, and so on. And along with that, within the Vault container itself, there is the shell, and there are some other binaries as well, which are maybe needed, maybe not needed, maintenance binaries. You can compress the image and remove all those. But again, Vault default image does not remove all those. So what happens is, since you have all these, when someone comes into the picture, when a hacker man, to say, comes into the picture, they are able to figure out, like, based on their experience or whatever they have, like, they know that your Vault might be storing data in this way, and they might use some others like targets. Basically, they might target your microservices, and through those microservices, they might break out of the containers and then access the Vault container. Or it could be some vulnerability within Vault itself that lets them do this. Or it could be some binaries that are stored. The possibilities are limitless. So what happens is there are a couple of threats that are present here. There is most like vulnerable thing is the data itself that's present here. An attacker could gain access. A little bit of a Mr. Robot reference. I'm not sure how many of you know about it, but basically in this series, like, some attackers gain access to an organization's database, and they corrupt it, and they basically launch a ransomware attack against it. So Vault is a primary target for a ransomware attack, because the moment your keys, your secrets get encrypted, you are left helpless. You can't do many more things, right? So we have seen, like, attackers generally target this. They encrypt the data that's present in Vault, and then they demand some ransom and so on. So since this is out of the way, let's see how our attack campaign has been going on. We have all these commands being run, and you see this was a simple ls. This tried to run a cryptominer in the container, in the Vault container, and it could be used for, like, mining cryptocurrency, and it could cause performance degradation and so on. And then there are some other processes, and yeah, so since this is executing still, I hope it's internet here. So this was the last vulnerability. Like, this is the pawn attack. Basically, it's copying all our data and storing it elsewhere. Now, before that pawn attack happens, let me show the data that's present in Vault right now. This is the Vault UI. I have Vault deployed and exposed through a service. And you see, I have a good enough secret here. I'm not going to show real secrets here, but this is kind of similar. And right now, in an ideal state, this might be what your Vault looking like. But yeah, since this is successful now, I'll just quickly show you what the attacker has done. Okay, I have been pwned. And they have left some data. They have left a ransom amount. They have left a wallet ID, so just for fun and stuff. But yeah, basically you saw that I did not myself execute any command. All this happened through the agent that Caldera is running there, and it has been receiving all these commands and doing all this. Now, the next step here would be like what we follow is once we have shown what can happen, we show how you can prevent it. So very quickly, we have an open source project called KubeArmor. You've heard about it. KubeArmor does runtime security. So the moment we install KubeArmor and we apply some of the policies that we have, for example, on this part, we have a lenient allow policy. What this policy basically says is that the write access and read access to the vault directories should only be allowed to your vault binaries and nothing other than that. So when I'll enforce this binary, you won't be having this. Let me quickly install KubeArmor on this cluster and I'll quickly keep the policy ready as well that we're going to apply. The policy is here. So and the moment we apply a policy, you'll see that I'll again run the set of things that the Caldera setup was doing. I've applied a policy, oops. And let's rerun the Caldera. It's going through a cleanup right now. So when I rerun, since KubeArmor is in picture, you would see that these events have started getting permission denied, all those nasty executions that were happening. And yeah, when like this will take some time to complete, and I don't think I have so many time. So you'll see that we'll get a couple of failed commands here. We'll get a couple of permission denied here because we have an agent in place which is making sure that things like these don't happen. So I'll quickly get back to the slides. And we've seen how we basically demo all this. And this has been prepared by the folks at AccuKnox, the solution engineers, and Rahul Jadhav, and many other folks. And we are trying to create an ecosystem around this tool. Like we are creating a knowledge base of what all can be done with Caldera, what all vulnerabilities are present, and how people can test their systems against these. So here are a couple of references. You can check these out, and yeah, would love to see you around. Any questions?
I'm sure there are plenty of questions, but probably take them offline.
Okay.
Since
yeah.
Since cutting close on schedule. But thank you so much. I think